What if I told you that some of the most important discoveries about the universe didn't come from visiting distant worlds, but from simply looking at them in the right way? That's the power of space telescopes. Floating above Earth's atmosphere, they don't just take prettier pictures of space. They reveal a hidden cosmos, planets around other stars, galaxies from the early universe, black holes feeding on matter, and even invisible dust clouds where new stars are born. Today, let's look at 5 amazing ways space telescopes reveal the universe and why each one matters. First, space telescopes can observe wavelengths of light that never make it cleanly to the ground. Earth's atmosphere is great for life, but not for astronomy. It blocks a lot of ultraviolet, infrared, and X-ray light. That's a huge problem because some of the most important cosmic events shine brightest in those invisible bands. For example, infrared light can pass through dust better than visible light. That means telescopes like James Webb can peer into star-forming regions and see newborn stars hidden inside thick clouds. It's like turning on a flashlight in a foggy room, not because the fog disappears, but because the right kind of light gets through. This is useful because astronomers can study how stars and planets actually form, instead of guessing from incomplete data. Second, space telescopes can look farther back in time than ground-based telescopes. That's because light takes time to travel. When a telescope sees a galaxy billions of light years away, it's not seeing it as it is now. It's seeing it as it was billions of years ago. Space telescopes like Hubble and Webb have captured galaxies so distant that their light began traveling when the universe was still very young. This helps scientists answer big questions. How did the first galaxies form? When did stars first appear? How did the universe go from mostly hydrogen gas to the complex structure we see today? A concrete example: if a distant galaxy looks small and redshifted, astronomers can estimate how fast the universe was expanding when that light began its journey. That gives clues about cosmic history itself. Third, space telescopes help find planets beyond our solar system, and sometimes tell us what their air is made of. Most exoplanets are too dim to see directly because they're overwhelmed by the light of their host stars. But telescopes use clever methods like the transit method, where a planet passes in front of its star and causes a tiny dip in brightness. Even more impressive, when a planet's atmosphere is in front of the star, some starlight filters through it. Different gases absorb different wavelengths, creating a chemical fingerprint. That means telescopes can detect water vapor, methane, carbon dioxide, and other molecules. Why is this useful? Because it lets scientists compare alien worlds and ask whether any of them might have conditions suitable for life. For example, if a rocky planet in the habitable zone shows a certain mix of gases, that could make it a high-priority target for future study. Fourth, space telescopes reveal things we cannot see with our eyes, or even with ordinary instruments. Some of the universe is hidden behind dust, and some of it doesn't emit visible light at all, but it still leaves a trace. In X-ray and infrared astronomy, telescopes can detect energetic processes around black holes, supernova remnants, and galaxy clusters. A black hole itself may be invisible, but the hot gas spiraling into it can glow intensely in X-rays. This is incredibly useful because it allows astronomers to study extreme environments and understand how massive objects affect everything around them. For instance, when a telescope maps a supernova remnant, scientists can trace the elements scattered into space, elements like oxygen, carbon, and iron. In a very real sense, space telescopes show us where the building blocks of planets and even life came from. Finally, space telescopes are not just about wonder. They are tools for understanding how the universe works in practical, measurable ways. They help refine models of gravity, dark matter, galaxy evolution, and the expansion of the universe. That might sound abstract, but these models shape everything from how we interpret data to how we design future missions. For example, studying how stars live and die helps scientists predict where heavy elements are created. Studying exoplanet atmospheres teaches us how to analyze faint signals from tiny chemical traces. And studying cosmic structure helps us understand how matter clumps together over time. In a way, space telescopes are like time machines, chemistry labs, and cosmic detectives all at once. The hidden cosmos is not hidden because it's far away. It's hidden because our eyes alone aren't enough. Space telescopes give us a different set of senses, and when we use them, the universe becomes far more detailed, more dynamic, and honestly more astonishing. So the next time you see a beautiful image from Hubble or Webb, remember, it's not just a picture. It's evidence, it's history, and it's the universe revealing secrets we were never meant to see with the naked eye. 5 amazing ways space telescopes reveal the hidden cosmos is just one small part of space telescopes, Hubble and Webb. If you're interested, our full free space telescopes, Hubble and Webb course is linked in the description.